Can a belated general still stage a comeback at the high-stakes poker table, where the smoke of battle already hangs thick? Recently, remarks by Russian test pilot Sergei Bogdan have thrust the Su-75 Killshot back into the spotlight, a project military enthusiasts had nearly relegated to the realm of PowerPoint aircraft. This ill-fated single-engine stealth fighter is now slated for its maiden flight in early 2026. This news sent ripples across the calm waters, like a pebble dropped into a lake. Could this once stunning model at the Dubai Airshow truly be brought back to life? From its inception, the Su-75 was never intended as a showcase of technological prowess, but rather a high-stakes, cost-effective gamble born of extreme pressure and distinctly Russian characteristics. Its design philosophy bears the deep imprint of real-world constraints, amid severe Western sanctions that nearly severed supply chains for high-end chips and precision components. The Russian aviation industry's primary mission was survival and finding a breakthrough. Thus, the Su-75 took a shortcut through simplification and reuse. It heavily leverages mature technologies and manufacturing processes from the heavy fifth-generation Su-57 fighter, aiming to win market share by reducing production and operational costs. Its core logic is to assemble the optimal solution using existing components. For instance, it likely employs a derated version of the Su-57's Product 30 engine, while its avionics systems may be modified from the Su-35 series. The advantages of this approach are clear. It significantly shortens the R&D cycle while reducing technical risks and costs. Russia claims its target unit price could be around $30 million, less than one-third of the US F-35's cost. This figure is undeniably tempting for many nations, with limited budgets yet eager to acquire stealth capabilities. Guided by this philosophy, the Su-75 exhibits a remarkably aggressive yet pragmatic physical form. It features a unique under-chin air intake and a V-tail configuration. This design eliminates complex intake adjustment mechanisms, contributing to weight reduction and manufacturing simplicity while also offering some radar stealth benefits. It is also the world's first medium-sized stealth fighter claimed to incorporate a side-mounted weapons bay, with 3 internal bays planned to maximize weapon carrying capacity within its limited size. On paper, its specifications are impressive: a maximum speed of approximately Mach 1.8 to 2, a payload capacity exceeding 7 tons, and an operational radius approaching 3,000 kilometers. However, these seemingly cost-effective designs come with significant question marks. While a single-engine configuration is economical, the power redundancy and safety provided by twin engines remain irreplaceable lifesavers in the high-intensity, high-conflict environments of modern warfare. The chin-mounted air intakes, designed for stealth and simplicity, must undergo rigorous real-world flight testing to verify their ability to maintain stable, efficient airflow during high angle of attack maneuvers, and to assess the stability of their stealth characteristics. Thus, the Su-75 appears more like a solution squeezed out of a tight spot, a case of making do with limited resources and constrained supply chains, relying on deep technical expertise to achieve the impossible. Its primary advantage has never been absolute technological supremacy, but rather extreme price appeal and precise targeting of specific market niches. Its maiden flight represents less a grand display of technical prowess than a survival test of Russia's aerospace supply chain resilience, fundamental R&D capabilities, and project integration skills under Western sanctions. Shifting focus to the J-35A reveals a distinct and more confident technological trajectory. The J-35A does not exist in isolation. It forms a complementary air-sea combat system with the carrier-based J-35 variant. This implies its development is anchored in the demands of a vast, mature, and rapidly expanding defense system, one encompassing advanced carrier strike groups and Air Force combat capabilities. From its design inception, the J-35A resolutely embraced a twin-engine configuration. This choice not only endows it with superior thrust and enhanced safety redundancy, but also lays a solid foundation for undertaking more demanding missions and unlocking deeper performance potential in the future. Its aerodynamic layout exhibits a mature, streamlined form honed through countless wind tunnel and digital simulations, pursuing the ultimate in omnidirectional, full-spectrum stealth. The 3 core technologies summarized by its chief designer, academician Sun Kong: invisible stealth design, high information integration in a compact form factor, and adaptability for both catapult and ski jump takeoff modes, all point toward the future of networked, intelligent air combat. More importantly, the J-35's development has been steady and rapid. It has made public appearances at military parades, and images of its green-painted production models have been officially released to the public. Notably, the carrier-based variant J-35 has successfully completed its first catapult launch and arrested landing training on China's electromagnetic catapult-equipped aircraft carrier, the Fujian. This marks its crossing of the most critical threshold for carrier suitability, entering a phase of combat-ready training, focused on deep integration with the operational platform. Military experts assess that the J-35's overall performance now leads among carrier-based aircraft. Its flight speed, maneuverability, radar detection capabilities, and combat radius all surpass those of the US F-35C, while its stealth performance holds a distinct advantage. This indicates that the J-35 series is not a follower but a top-tier air superiority and multi-role fighter designed from the outset to meet global benchmarks. It does not need to overly emphasize cost-effectiveness, as its goal is to achieve optimal performance within a fixed cost framework to satisfy the rigid demands of major air and naval forces for high-end combat capabilities. Thus, when comparing the Su-75 and J-35 superficially, they appear as products from parallel universes. One is a vanguard seeking to break through sanctions by leveraging low prices to penetrate foreign markets. The other is a core component steadily developed within a complete, healthy, and rapidly advancing industrial system to meet domestic high-end operational requirements. The Su-75's claimed 3,000-kilometer combat radius is likely achieved only in ferry configuration with auxiliary fuel tanks, while its true tactical operational range remains unproven. In contrast, the J-35A, supported by China's expanding aerial, refueling fleet and aircraft carrier platforms, possesses generational advantages in operational flexibility and mission adaptability. Regarding the critical avionics, radar, data links, and weapon systems, it remains a significant unknown whether Russia, severely constrained by sanctions, can equip the Su-75 with truly fifth-generation standard brains and nerves that are both reliable and free from external constraints. Behind the J-35 lies China's comprehensive and rapid rise in electronic information technology. Its highly integrated information and networked capabilities are precisely the core force multipliers of modern air combat. Thus, returning to our initial sharp question, can the belated General Su-75, in its design, outmaneuver the J-35A, which has long seen through everything? The answer may be somewhat brutal. In terms of pure technological advancement, system integration, and developmental maturity, the Su-75's design philosophy never aimed to surpass opponents like the J-35A. Its battlefield lies in another dimension, the international arms trade market. There, its rivals extend beyond the J-35A to include the American F-35, French Rafale, Swedish Gripen, South Korean Kf-21, Turkish Khan, and a host of other competitors. Its greatest weapon is the alluring $30 million price tag, coupled with flexible cooperation proposals, including joint production and technology transfer, offered by Russia to traditional partners like India, Vietnam, and Algeria. Its path to counterattack hinges on attracting critical investors like India, ensuring a smooth maiden flight and subsequent test runs, and delivering performance that lives up to expectations. Only then can it convince potential buyers that it represents a reliable, affordable stealth solution. In short, the 2026 maiden flight is pivotal for the Su-75. A successful debut could position it as an active, influential player on the international arms trade chessboard, realizing its commercial value. However, if it aims to challenge the J-35A, which has already cleared critical thresholds, integrated into robust combat systems, and continues to evolve in a technological showdown, this general's race was likely destined to be one with different objectives from the moment the design drawings were finalized.